Hello and welcome. This is my video for week 1 of Activity 2. My objective was to secure a Python backend API created with Fast API. The original code base had significant security flaws, specifically regarding hard-coded credentials, CWE 798, and insecure cross-origin resource sharing policies. So in this video, I will walk through the code, refactoring, the environment configuration, and finally, there's a live demonstration analyzing the network traffic. Let's start with the backend code in main Python. So in the previous insecure version, the secret key used to sign the tokens was hard-coded as a plain string, so this is a critical vulnerability. Now in this new code, I implemented the Python.m, as you can see here, library. So as you can see, I am now loading the secret key, the algorithm, and the expiration time directly from the operating system environment variables. I also added a safety check. If the environment variables are missing, the application will raise a value error and refuse to start, preventing secure deployment. So the actual secrets are stored in this local env file, which is excluded from the version control systems like Git. Now let's go back to the main. So we are going to explain the course middleware. So moving on to network security course, controls which domain can interact with our API. Using this, here is dangerous. So I have replaced the wildcard with a strict whitelist. I especially allow a localhost on port 5500, and that's because that is the specific port where my front-end application will be hosted. So any request coming from a unauthorized port or domain will be blocked by the browser at the network layer. Let's open the test HTML. So let's examine the client-side logic. So the authentication flow has two steps. Here first we have the login function with post credentials to the server and receives a JSON web token which is stored in our memory. Also crucially, we have here the authorization bearer. That here is the access protected function. To access secure resources, we must send the token in the HTTP headers. We use the standard schema key authorization and value bearer followed by the token string. This is the industry standard for stateless authentication. So now let's gonna test it. We are gonna open a new terminal here. We have to execute this code, this script. 1 second. Okay, so now I launched the infrastructure in this terminal. I started the Fast API backend using Ubicorn on port 8000 and it successfully loads the secure version. Now let's gonna open a second terminal in which we are gonna start the front-end server to match the course policy I defined earlier. So if I use a different port, the connection will be refused. So now let's gonna test it. We are gonna open the browser. 1 second. And here we're gonna test the application. So I request a token, the server validates the user and returns a signed token, and here's the OK response. As you can see, we received our token. So now let's gonna access the protected data. If we inspect the request headers, we can verify that the authentication header is being sent correctly with the bearer token. So the server validates the signature and grants access. The system is secure and functional. Thank you.